This video will cover section number 4 of your Unit 4, Unit 5 flipbook, section number 4, just the top flap of section number 4. And the essential question in this section is, how do I factor? The essential question is, how do I factor? Now I want to make a note right above here, class. Okay, just so you guys see this, what is factoring? We'll talk about it more in class. But what is factoring? Essentially, this is what factoring does. Actually, I just realized, I didn't notice this, class. I had the wisdom to actually write this in the flipbook. I added this from last year. So let's answer the question by what I already typed in for you. Factoring means to change a standard form quadratic to intercept form, so we can find the exact x-intercepts. Remember, x-intercepts can also be called zeros, they can also be called roots, and they could also be called solutions. So in previous videos, we've learned how to take a vertex form quadratic and change it to standard form. We've learned how to take an intercept form quadratic and turn it to standard form. Both of those are done by distribution. And now we're going to go the opposite direction. How do we take a standard form quadratic and change it to intercept form? Remember, class, standard form quadratic, the things that it gives us that are nice, as if we're talking about projectile motion, like a football in the air, or a diver, a trampoline, any of those things, something in motion being pulled by gravity. If we're graphing height over time, then the standard form gives us the initial velocity. Actually, technically it's the initial vertical velocity, and that also gives us the starting height of the object. So that's the reason why we would want to change intercept or vertex form to standard form. We want to change standard form to intercept form when we want to find the x-intercepts. In our examples in class, we were able to graph standard form, but most of the time all we were able to do was estimate the x-intercepts, not find them exactly. So by changing from standard to intercept form, we'll now be able to find exactly where the parabola crosses the x-axis, which works really great for projectile motion because we'll be able to tell exactly when an object comes back to the ground and hits the ground. Alright, so here are the steps. I've pre-typed them in for you so you can easily read them. The first step of factoring in is put the terms in proper order. Let's go ahead and do a sample problem here on the right side, and we'll kind of work through this as we go through the steps. So let's write a sample standard form quadratic equation. Y equals 4x squared plus 12x minus 40. And before I go to the next step, I want to caution you, class. You're not going to grasp this by doing this one time. Now, some of you already know how to do this, actually, but most of you do not. You're going to have to go through a number of practice problems to get good at this, and really, it might take you a whole rest of the year practicing them to get good at it. But don't think by looking at my steps one time through, you just say, oh yeah, I got that process. You got to practice it a number of times. We'll go through a couple practices after we go through this video. So put the terms in proper order. That means I want the squared term first, the term with an exponent of 1 second if it exists, and the constant term or the c value at the end. You got to put them in proper order before you start. Sometimes you're going to get equations where these are all mixed up. Put them in the right order before you continue. So step 1, we'll just put on here, step 1, check. It's already done. So actually, you know what, let's do this. Let's just rewrite the equation so we know in proper order. In fact, I probably should have written the equation out of order, but if you guys are listening to the audio, you will understand what this step is doing. And in this case, we don't have to do anything for this step. Alright, step number 2. If A is negative and or there is a greatest common factor, then factor it out. So we're going to look at the A term here. Let's take a look. Is a negative in this case? We say no, it's not. So we don't have to factor out the negative or the -1. Okay, you'll see some more examples you'll see when we do that. The next question is there a GCF? Okay, so I'll put on here, let's put a little note here. Is a negative? No. Okay, is there a GCF? And when I say GCF, we're looking at the coefficients of every term, 4, 12, and -40. And the question is there a common factor between all 4 of those numbers? Now, sometimes it might take you a few minutes to figure this out, but I can see that 4 goes into itself. 1 times 4 is 4. 4 goes into 12. 3 times 4 is 12. And 4 goes into 40. 10 times 4 is 40. That means we do have a GCF of 4. And because of that, we want to take that out of the equation. Now, you'll not always have that. If you've got an a value of 1, there'll be no GCF. Well, the GCF is 1, but that doesn't do anything. There's no reason to pull a 1 out. So in this case, I'm giving you a little bit harder factoring. So we're going to pull the 4 out. So y is equal to, I'll pull the 4 out, and now let's figure out what's left. Well, I'm just going to do the reverse here to figure out how to get back to our original. 4 times what gives us 4x squared is just x squared. 4 times what gives us 12x? Well, that's 3x. And 4 times what gives us -40? That is -10. So you see what I just did was I took a common factor of all 3 of these terms and I pulled it out of the equation. And if once you do that, class, the best thing to do is go back and check your work. Recombine these and see if we get back to the original. 4 times x squared is 4x squared, boom. 4 times 3x is 12x, boom. 4 times -10 is -40, boom. So we know we have done it correctly. That is step number 2. Step number 3, we're going to identify A, B, and C. And now class, you have to identify A, B, and C in the new trinomial here, in the new quadratic. You ignore the 4 now. So now we see that the A value is now equal to 1, the B value is equal to 3, and the C value is equal to -10. So we found the A values, the B values, and the C value. All right, there's our step 3. Now, step 4 is a complicated one. Split the B term into 2 terms with coefficients that multiply together to equal A times C and add together to equal B. Now there's a nice way to organize this. You draw what looks like a big I and you put A times C on the top of this. I gave you a little helper right here. A times C on the top and the B value on the bottom. Let's do this. A times C is 1 times -10. That's -10. That goes on top. The B value is 3. That goes on the bottom. And now what we have to do is we have to find 2 numbers that when we multiply them, that's why I put a times here. When we multiply them together, we get -10. And when we add them together, we get 3. The way you do this, class, is it's like picking a lock. You're going to start writing down all the numbers that multiply together to give you 10. Ignore the negative for now. All the numbers that multiply together to give you 10, and see if we can add them together and give 3. So I always start with 1. 1 and 10. Well, if either one of these numbers were negative, -1 times 10 is -10, or 1 times -10 is -10, so those are correct numbers. Can we add these together to get 3? Now remember, one of these terms has to be negative so that we get -10. So let's try 10 minus 1. Well, that's 9. No good. Let's try 1 minus 10. That's -9. No good. So the first 2 terms are out. Let's try the next one. I know that 2, my next number, goes into 10 5 times. 2 times 5 is 10. If one of these is negative, we'll have -10. Let's check and see if we can add them together to give us 3. So, -2 plus 5, oh, that's +3. So if I make a -2 here, perfect. -2 times 5 is -10, and -2 plus 5 is positive 3. We just found our combination that we're looking for. So that step is done. What we're going to do now as we write this out is, for step 4, we're going to split these two terms out. Now watch what I'm going to do. I'm going to take my original equation from question number 2, and I'm going to write y equals 4. And now I'm going to write x squared, but instead of writing 3x here, I'm going to split it out between these two numbers. I'm going to write negative 2x plus 5x, and now I'm going to write my negative 10. Now look, class, you've got the exact same equation from step number 2. The only difference is we just took the positive 3x and we made it into negative 2x plus 5x. We already have verified that those two numbers added together give us 3x, positive 3x. Let me fix this real quick, and I'm going to run out of time, but let's try to get this right. This is 5x. Okay, step number 5. Guess what? Grouping. This is what we've learned when we've been distributing. Group the first two terms in factor and group the last two terms in factor. So watch what I'm going to do. I'm going to write this equation out. Y equals 4, and now watch what I'll do here. I'm going to take the first two terms and I'm going to factor them. So take a line. Let's go ahead and draw a line under the first two terms. Let's factor them. Do they have a common factor? Absolutely. Their common factor is x. X is in both of these terms, so I'm going to pull out an x, and now I'm going to write what's left over. X times x is x squared. X times negative 2 is negative 2 squared. Now notice, class, all we're doing is the reverse of distribution. Instead of multiplying the terms in and getting this out, we're pulling out the common term. And notice, x times x is x squared. X times negative 2 is negative 2x. We haven't changed anything. And now we'll go ahead and do the next two. Let's group these and find the common factor. So I'm going to put a plus, because I have a 5 here, a positive 5. The common factor here is 5. Take a look. 5 times what is 5x? That's x. 5 times what is negative 10? That's negative 2. Now class, when you get to the end of this step, the cool part is you end up with the same binomial on the first term and the last term. X minus 2 and x minus 2. If you don't get that, trust me, you've made a mistake and you got to go back and fix your work. Let's do step number, that was grouping. So we did 4 and 5 right here. I'm going to make a little note here. We already factored out the, oh, wait. Sorry. We got this right. This was 4. This was 5. And step number 6. Step number 6 is factor out the common term. Now what that means is, I'm going to rewrite this, y equals 4. Take a look. Here's our common term, x minus 2. I'm going to do the reverse of what we did with distribution. I can take the x and the plus 5, and I can write that together. And then I'll take the x minus 2 that was the common term, and I put that together. And if you look, class, just look. All we did was the opposite of what we've been learning in class before when we were combining or distributing polynomials. We just did the exact opposite of what we did before. Instead of doing x times x minus 2 plus 5 times x minus 2, we just took what that looked like and we went the opposite way. This common term, x minus 2, can be written on the end, and the x and the plus 5 can be combined together in a binomial. Again, do a bunch of these, we'll be able to get it. Number 6 now shows our factored form, and this is now an intercept form. And if you look at step number 7, it says, don't forget to keep the GCF you may have factored out in step 2 in your final equation. We did that right here. Our GCF was 4. We kept it in every step the whole way.